Hey everyone, Chinese Man here. Today I'm going to try to flash code a Leetcode Yeezy Excel sheet column number. It doesn't seem like it's going to be a very common question, but it seems like it had a lot of thumbs up, so might as well do it. So let's get started. So first I'm going to read the question. Given a column title as appear in an Excel sheet, return its corresponding column number. So A1, B2. Okay, so it goes past Z, and so it's kind of like converting Excel's A1, C1. I mean, forgot what it's called, but it's converting Excel's A to Z on the top and 1 to whatever to R1, C1 format. So essentially converting the letters to a number. This looks like it's just the column number, so it's not even converting the cell reference. It looks like it's just pretty much not even Excel related. You can just say converting a letter to a number. So let's think about this. We're given a string with the letters and we want to return the number back. We could create a map of A to Z and having the values 1 to 26. And then from there, we just process each string. Which should work. But keep in mind that AA, for example, is not, I guess, 2, it's 27. So it seems like the second position. So let's, I guess, do some examples. A is 1. AA is 27. What about AAA? So that third A means that the second letter, the A in the middle, has already gone all the way to Z. So this is the equivalent of ZA or ZZ plus 1. So I'm trying to find a pattern. So for example, the last letter is always going to be between the 1 to 26. The second letter, the difference between an A versus a B. So for example, if it's AA, it's 27, but if it's BA, that means it went through another 26. So 27 plus 26. So that is 40, 53. Well, 53 doesn't really, I guess, give us a relationship. But the 26 plus 27 plus 26 does give us a relationship. So we went from this A to the B, it added another 26 to it. Now, if we went all the way to Z, then that's just the original 27 plus 26 by 25, I believe. Because there's 26 characters, but B is just by adding 126 to it. So that's kind of like the relationship there. So therefore AAA would be 27 plus 26 by 25 plus another 26. So it's I'm thinking. So notice that the second letter just multiplies that 26 times whatever. And a third letter going from, for example, AAA to BAA would mean that that whole thing gets increased again. So let's convert that into 26 plus 1, and that's 26 times 2. So if we actually do this, it actually looks a lot more like there's a pattern going on, because then you have the character value. Each time it increments, it just adds 26 to it. So here we have interesting. Well, we're still trying to find the pattern here, but in the meantime, I'm going to have to find a mapping of A to Z to 126. Now, there's two ways I can do that. I can either create a map of the letters and values. So, for example, A is 1, B is 2, and so on. I'm going to have to create that once, or I can use a JavaScript function that will convert. There's a character to number function. It's not exactly 1 to 26, there's an offset somewhere, but I can just MDN that real quick. So MDN character code. So that represents, yeah, that is a completely different code as UTF-16. We just want to find the letter. So MDN letter to number. And seems like it actually is this, which is not as friendly as I would like. This just returns a Unicode value. Well, if anything, we can just use the first method. So for example, we can just do const map. Actually, I'm pretty sure there is a function. Let me just do one more quick check for it. Yeah, can't really. Oh, so it seems like the 65 is where the uppercase starts. So it's probably something that's lower than that for the lowercase. So let's just test that out. So for example, we can just go back to here and let's test out the conversion. So given a string of, say, lowercase a, b, c, and then we want to get car code at 1, for example, and let's console that out. So this will get us a, b, and c. actually it's looking for uppercase, so actually that should be exactly this. So starting at 65. 65 is A. So we know we'll have to iterate through the string. So for let I equals 0, I less than s dot length, I plus plus, and then const current character is s dot car at I. Const current number is s dot car code at I minus 65, I think was the number. 65. So 64, and then console log current number. So that should give us the number of the characters. So here let's just test out A should give us 2 and 1. So yeah, it gives us 2 and 1, so that pretty much maps it to the number. So A1, B2, C3, and so forth. And here we actually want to do it from the reverse, because the last character is just a straight number, but depending on what period of what digit we're at, the second character, for example, is 26 times that number. Or we can actually do it from left to right as well. We just need to keep track of the length and have that multiplication in there. So what do we know? We know that the first digit is just 1 to 26. The second digit, our second character, is that n times 26. Third digit should be n times 26 times 26, I think. But we'll do a test on it, see if that works. If not, there might be an offset in there somewhere. So let's look at this now. And then we look at what level of significance we're at. We can const significance equals to 20 math.power. So this takes the power of a base to an exponent. So it's 26, and then the character length that we're at. So for example, it's the first character and then 0. If it's second character, then it's 1. So that will be s.length minus I minus 1, I believe. First we'll declare a result variable outside, starting at 0, and then we'll just add result equals result plus that character's value, which is current number times the significance. And then we'll consult the progress of it. So we're currently at current number, and that will add current number times significance to the final result. So this way we can check to see if we're doing the mathematics right in between. So 2 adds 52, 1 adds 1. Given this runtime environment though, we could just add any test case, but in an actual phone call, for example, you might not have this runtime environment with the correct output to be compared against. So you want to check this internally as well. So for example, if we have here, we have the AAA should be 27 plus 26 times 26. Let's see if that works. And it does, because 703 is just 2 more from there. So ZZ AAA. And that seems like it'll work. So we can delete this long-winded example where we were going through the different cases. And then we can also delete out the console log so that it run faster. We don't really need this current character at, but it's just helps for debugging. For example, you want to look at what character maps to what number, assuming that's line 11 didn't work. And then we'll just submit and hope some edge cases doesn't blow it up. And it works. So I guess yay for low memory usage. A little bit faster than average, but wasn't very impressive either. That being said, Leetcode, the statistics on runtime isn't always accurate. So if you click submit multiple times, it can vary quite a bit. So I guess let's look back and see what happened here. We had this problem where we're converting letters to numbers. That took a bit of time to figure out, but the bigger time that was taken was on figuring out what about at the later digits of significance. So the first one about converting A1, B2, C3, that one was just finding the right JavaScript function. If you're not allowed to look up docs, you can always just create the map yourself using an object or map object. The second one about the multiple characters and iterations, that one just required a bit of testing. Finding a formula, but it's very easy to get offsets wrong, so it's always good to have test cases to see whether it works or not. In Leetcode, you have the function that they have that they'll do the correct calculation for you, so that's a little bit easier to test. But if not, you just kind of have to do it by hand. So for example, what is ZAB? Calculate that by hand, test it to see if it works, and then we'll kind of go from there. So let's look at the time complexity. Time complexity is we go through each character once using this for loop, and then these conversions are fairly linear. This maps to the power function. As it gets bigger and bigger, I'm not sure how it runs this in the backend. Maybe it's just taking the same number and just adding it n times, for example, or do something more efficient. But that will also grow as the length grows as well. So it's either big O of n or big O of n squared. I'm guessing it's probably big O of n, but I'll have to look into this map power function to see what happens to it as the exponent increases. On the space side, it's pretty linear. We're not. It's O of 1. It's not really creating more variables. These variables get reused every time. Instead of declaring and redeclaring, we could just declare this outside like we did here, and that way it's just reassigning. But then it also includes our global namespace. Actually, not even global namespace. It includes the namespace inside the function. So that's probably one enhancement, is to just do let current number equals that. So that way we're just reassigning, and we got rid of that first one for debugging. This should make it run a bit faster. For example, if I submit again, and that runtime is going to be really variable, so we don't really know. See, it actually took longer, which is surprising. If we run it again, submit it again, it might not. or not. That's surprising though. So it actually took longer when we're declaring this outside and then just reassigning it versus redeclaring this every time. Why is that? I don't know. We can actually see if that's going to be a performance difference, because if we actually let significance outside as well, that means that effect gets leveraged by 2 to see if indeed that will hurt performance compared to improving it. So that kind of went the other way around. So it increased due to letting the current number be reassigned instead of redeclared and assigned. But then when we put significance out, it did the opposite. So I'll have to search that up. Might do a brief thing in the comments or in another video about this. But that's kind of like the post-mortem of what we did here. In terms of I guess improvement, being aware of this car code function is pretty useful. I've seen it in a few problems before, but it's not really needed to solve the problem. The testing part, it's going to be there. You can't really get around it. But overall, yeah, this is Leetcode easy, but takes a little bit of experimenting with, so it's not really a problem that you can for sure get right on the first try. There's a lot of spots where you might be offset by 1, for example. So just make sure you take your time, be careful, and good luck. Hit subscribe on the channel. I'll be doing more of these problems. If it says Flash in the title, it means it's my first time looking at it. If it says review, that means it's reviewing problems that I've looked at before, just for full transparency to the user.